Hello everyone, welcome to episode 4 of the screencast, where we are finally going to deploy our stuff on Kubernetes Engine. So the first thing we're going to want to do is we are going to need a command called kubectl. CTL I believe stands for control, so kube control is kind of how you can think of this command. And if we tried to run this right now, it's not going to be found because by default it doesn't come with the Google Cloud SDK. So the first thing we're going to want to do is, and also you can verify that if you type in gcloud components list, it's going to show you all the stuff that you currently have installed and all the stuff that you could install. And at the bottom there you'll see we have BQ installed, we have core stuff installed, and GSUDIL. So right above those three, the fourth from the bottom there, you can see kubectl is listed. So in order to install kubectl, we're going to type gcloud components install kubectl and hit enter. And it's going to ask us to continue, so it's going to install that for us. And then if we type kubectl again, it's going to give us some output here. So yeah, so do that first. And then if we look at the output here, we can see a lot of different commands that we can run. They have some grouped here under beginner stuff. You can type kubectl create to create a resource, expose, run, set. One of the most basic commands we will do will be get. So if we wanted to look at all the pods we have running, we would type kubectl get pods. So we could try that out right now. If we type kubectl get pods. Okay, so actually the first thing we have to do is right now by default kubectl is looking for Kubernetes to be running locally on our local machine on port 8080. But that's not the case, so we have to tell it how to connect to our Google Cloud cluster. So in order to do that, gcloud comes with a command called gcloud container clusters get credentials, and then we have to give it the name of our GKE cluster. And I actually forgot the name of mine, so I'm going to type gcloud container clusters list, and that's going to give me the list of all the clusters I have running. So standard-cluster-1 is the name of my cluster. So I'm going to type gcloud container clusters get credentials standard-cluster-1. Oh, whoops, I guess I need to specify a zone or region here. So I'm going to specify a region of US-Central 1. Oh, okay, I guess I need to do 1-A. Okay, now if we do that again, kubectl get pods. It's doing something and it didn't find any resources. So it did successfully connect to my GKE cluster this time, but it didn't find any pods running. So that's good. And actually I'm going to real quick set some config values so that I don't get nagged for the zone or the region, hopefully, going forward. So now that we've got kubectl installed, we are ready to start writing our Kubernetes manifests and using kubectl to create Kubernetes resources with them. So to that end, I've opened up the Rails app here in my code editor, and I'm going to start by creating a new directory for storing our manifests in. I'm just going to call it deploy. And I'm going to start by creating our first file here. I think the best thing we should start with is creating a job to do our database migration, to create the database and run the initial migration. So if you recall from the documentation we looked at, every job starts with an API version of batch/v1, and the kind is going to be set to job, and it's going to have a metadata field, and we can give it a name of, say, DB migrate, I think is fine. And then for our spec, we need to define how many completions we want to have. If you recall, jobs will run until n number of completions are done. So for a database migration, we only care about one being done. And now we need to define our pod template. So for that, we can set a metadata field for our pods to use. And we can set a name to be, say, I think DB migrate's fine. these resources will all be prefixed differently, so even though we have a name of dbmigrate for our job, most commands will take a jobs / prefix in front of that. And for these pods, when they're part of a template generally, when the pod's created, it will have this name prefix, but it'll end with a dash and then like a random collection of letters and numbers there, so this won't be the exact name of the pod anyway. So then for a spec, we want to set a restart policy, which controls when containers are restarted. When the container exits, you can choose always restart, never restart, or on failure. We never want to choose always because that would just run forever and never stop. And what we want to choose for this one is never, because if the job exited for any reason, we basically want to know and we want to investigate why that is. So then we want to set also a containers field that's going to define the containers in this pod template. And for that we want to set a name to be, whoops, I need an extra space there. We can set the name also to just be dbmigrate. For this purpose, it doesn't really matter. Now we need to set the image to whatever our image is. And if you can't remember what the image is, we can easily look that up with gcloud. If you go to gcloud container images list, that's going to tell you what you got. So for me, I got this here, and it's not showing the tag, but I believe the tag is :latest. And then we need to set args for what we're going to run with this. So we're going to run bundle exec rake, and then dbcreate to create the database, and dbmigrate to do the migration. And it's okay to basically always have this dbmigrate in your rake migrations, because it's kind of a no-op if the database already exists. And then the last thing we need to set in our container is we need to set environment variables, namely the database URL, so that our app knows where to connect to. So to do that, we need to set a Postgres URI string, PostgreSQL : // our username for our database, if you recall, is just Postgres, and I had set the password field to password. And for the host name, I don't remember that one, so I'm going to look it up. gcloud SQL instances list should tell us that. And we want to use the private address because we're using the private networking. So we can just copy that, paste it here. And then the last part of the URI here is just going to be the name of our database. So I'm just going to name it captioned images. And that should be good for our connection string. So if you don't remember some of this stuff, if you created a different SQL user and you forgot what the SQL user is, you can do gcloud SQL users list, and I believe you have to provide the instance name you're talking about, so you can just copy it from your SQL instances list command here. And that's going to show I just have a Postgres user, which is what I expected. If for some reason you forgot the password you had set, you can't retrieve the password in the console, but you can set a new password. So you could do gcloud SQL users set password, and oops, I don't know what that's about. But then if you were to pass it the username you're talking about, Postgres, and I believe you need to pass the new password like this. So you do password equals whatever. So I'm not going to do that because I know my password, but yeah. So this should work right now if we were to run this with kubectl. However, there is one little issue here. If we wanted to commit this to source control, we probably would not want to do that because we have our password right here in our file, and that's not really something you generally want to commit to source control. Luckily though, Kubernetes does give us a solution to this problem, and that is using a resource type called secrets, which I did not talk about in the last episode when I was talking about the different Kubernetes resource types we were going to use, but in any case, secrets are basically a way to refer to environment variables or files or other types of secret data that we don't want to be sticking right inside of our manifests. And the secrets are base64 encoded, so they're not super secure, but it does get the values out of our manifests, which is the important thing. They do have some use cases here you can look through. The command for creating a secret is kubectl create secret. Generic is going to be just for generic values. There is like a TLS type, and I think there's some special type for dealing with Docker registry stuff, but basically we're always going to use generic. Each secret has a kind of an organizing name that you can put multiple values under, so they call this one SSH key secret. And then you can pass in either from file or from literal, so you can read in a file and it'll set the value to that file's contents, or you can, if you do from literal, you just pass in the exact value and it'll store that value. So for our purposes we're going to be using literals, but in this example they're passing in from file and saying under this secret key name, SSH key secret, set a key of this key name to this value of this file contents. And they're doing that with two separate files here, so they're setting two keys, SSH public key, SSH private key, equal to their respective file values. And then they give an example down here of mounting those secrets as volumes, which are files. But for our purposes, they have another example where you can refer to secrets as environment variables, which is what we're going to be doing. And here's the env key, which is what we were setting before with the name. But then instead of us setting the value directly, we are going to be setting value from, and then the secret key ref with the name of whatever the key name is that we choose, and the name is going to be the name of the secret, and the key is going to be the key name. So we can go ahead and do that right now. So if we type kubectl create secret of type generic, and if you want to see the other types, actually, if you just type in -- help, it'll say here, yeah, here's the three types: Docker registry, create a secret for use of Docker registry. Generic, like I said, is what we're going to be using because we're setting a secret from a local file or a literal value, and then there's a special type for TLS. Anyway, so we are going to do that. We're going to do generic, and we are going to do, we could just organize these under one called app secrets for any environment variables we're going to set for our app. And then we're going to do -- from - literal, because we have a literal value, we're not saving contents of a file, equals, and then this is going to be the name of the key, so we can just call it database URL, and then equals again, and this is going to be the exact value we want to save. So we want to copy this. Our connection string here is going to be the actual secret value. We're going to paste it in and hit enter, and it's going to say it created the secret. Now if we were to type kubectl get secrets, it's going to show that it created our app secrets right there. And if we typed in kubectl edit secret, and we gave it that name app-secrets, it's going to bring up an editor. Shoot, I'm configured to use Nano instead of Vim right now. But anyway, it's going to bring up a editor that's going to let you edit secrets actually in line. If we created a bunch of secrets instead of just database URL, if we had more application secrets, they'd all be listed here. And this string here is the base64 encoding of the secret that we had provided. So it's a little weird that it's like base64 encoded here. So if you wanted to see this value, we could copy this out and do a base64 decode. But if you wanted to edit secrets using this kubectl edit secrets thing, you have to kind of pre-base64 encode your stuff when you stick it in here. So it's a little funky, but it's kind of an interesting thing anyway. So at this point we can replace what we had here before, this bare value. We're going to replace it with a secret key ref. So instead of having value, we will have value from, and it's going to be secret key ref, and the name of our secret key is the name of our secret is app-secrets, and then the key of the secret that we care about is database URL, and then we can delete this old value that we don't need anymore. So yeah, so that should be it for this. So we should be ready to run this now. So if we want to execute this and create this Kubernetes resource from our manifest, there are a couple commands we could do. One of them is kubectl apply-f and pass in the name of our manifest file. And this command is smart enough to either create the resource if it doesn't exist, or if we've already created the resource and we've made a change to the manifest, if we rerun it, it is smart enough to apply the change and update the existing resource. The other command we could do is kubectl create-f, which is explicitly attempt to just create it, not do updates. I always just use apply because it's just one less thing to remember, and also because if you create a resource with kubectl create-f and then later on you try to use apply, it will spit out a warning saying that you're only supposed to use apply if you created the resource with apply. It works anyway, but it spits out that warning, so it's kind of ugly. So I always use apply. So we will do that now, and we will pass in our path to our YAML file we wrote, and let's create it. So it's going to say that it created it, and now if we do kubectl get jobs, it's going to show that we have a desired count of 1. Successful is 0, meaning that it hasn't created our job yet. And now if we do kubectl get pods, it's going to show that our job is creating a pod there. You can see the db migrate prefix matches our our pod template that we specified in our job. And the status there of container creating means that it's still in the process of creating the container. So we can just we can either type, oops, there's an error there, so we'll have to look into what that means. It looks like it's trying to run the job again. So if we want to try to see why that errored out, we could look at logs for the container. So if we type in kubectl logs pods / and then one of the names of the pods, it looks like we have an error in our Ruby code. Excuse me. Okay, so we're missing secret key base. So we also need to set that environment variable, it looks like. So we'll just have to create another another secret for that. So we can delete our job, since the job is kind of messed up right now. It's going to keep restarting itself, trying to rerun it a few times. So we can do that by typing kubectl delete jobs / db-migrate, and that's going to say deleted it. Technically we don't really have to delete it, we can just leave it out there, and then when we update our job manifest and rerun kubectl apply, it's going to just update it, and it'll eventually try out the new code and it'll fix itself, but we might as well just stop it for now. So if we want to set a value for that, we can add another secret value for that. So we need to add secret key base, I believe. Secret key base. We can just copy this. We're gonna reuse the app secrets key, and we are going to just set secret key base. And the value we can set for that is, we can just copy what I used in the .env file for doing the Docker build. And obviously that's not something you would ever want to do in a real production build. You would want to type rake secret and get a fresh secret value to use for each different environment, but that's okay for now. So now if I want to add the secret key base key to my existing app secrets secret, we will be using the kubectl edit secret command that we had talked about a little earlier. But before we can do that, we actually have to transform the existing value we have, which is just the raw value. We have to transform that into base64 encoded data. So we can do that by piping it into base64 here on my Linux machine. I need to set wrap equal to 0 because if I do that, it all gets output as one line. If I didn't have that option, you can see it breaks. It adds new lines for formatting, so I don't want that. So we need the wrap equals 0, and I'm just going to copy that into my clipboard. So now, if I set my editor to Vim explicitly so I don't get nano, and if I do kubectl edit secret app-secrets, now I get a Vim editor that brings up the values in app secrets, which so far under this data here is just database URL. So to add our new secret, we just open a new line there and type in secret key base. And now if we paste in our nice base64 encoded secret and we write out and save this file, it's going to say it edited the secret, so it added our new secret to it. So now if we want to see that secret's out there, we can do a new command called kubectl describe, and describe is similar to get, but it gives more detailed information. So if we do describe secret / app-secrets, it doesn't output the data, but we can see the two keys are there. Our new secret key base is there with 128 bytes of data. So at this point you might be thinking to yourself, wow, that was kind of gross having to manually base64 encode stuff and paste it into that editor, and I would agree with you. And luckily Kubernetes has an alternative way to set these values, which I can show you now. If we go back into our kubectl edit secret app secrets, so before we were setting the data key and we were manually putting in these pre-base64 encoded values, we could also set a different key called string data, and this key accepts just the literal values of our keys that we want to set. So if we wanted to set secret key base to the non-base64 encoded version, we could do that instead, which is a lot nicer than having to kind of do the base64 encoding ourselves. However, the downside to this approach is that everything in the string data field will overwrite whatever's in data. So if we just tried to set secret key base, I believe the database URL field would be deleted. So if we want to do it this way, we have to reset all of the keys at once to the literal values. So I'm going to have to retype in my Postgres connection string here, setting my host and everything. Your host will be different, of course. But okay, so these are my two literal values, and then if I deleted the data key, and now if I write this out, Kubernetes should transform this whole block into the regular data field with the base64 encoded versions of these values. So let's try that out. And it's going to say it edited it. And now if we go back in to edit secret once again, you can see now that string data field is gone. It's been replaced with data and with the base64 encoded values that of the literals that we had entered. So that's another way to do things. It's got its own downsides, of course, with having to re-enter all the keys, but I guess you get to pick your poison on what you like to do. So now we've got our secret key base added to our secrets, and hopefully we fixed all the bugs we have. I'm going to be really embarrassed if we didn't and we got more bugs, but I'm going to assume everything's good. So let's go ahead and try to recreate our job. So I'm going to save this file. Looks like I didn't save it. And now we are going to once again do our kubectl apply. You know, actually before we do the apply, let's delete the existing job that's out there, just so we have a fresh slate when we recreate stuff. Okay, so now we're going to do kubectl apply -f and the path to our job manifest. And okay, now it created it. So now let's do get jobs. Desired 1, successful 0. Okay, now let's see what we got for pods out there. Oh, it completed, so that's good. Completed status is good news. So now let's look at the logs for that pod, for that container. And there we go. That's great. So it says it created the database and did the migration. So we successfully connected and did all that stuff, so we should be ready now to write our deployment to get our web server running. So first we can clean up this job. If we do kubectl delete job/db migrate, it deleted that, and that should have also deleted the pod that that belongs to that job. If we do get pods, this should be empty, which it is. Okay, so now we can write our deploy. So we can start that by creating a new file. We can call it deploy.yaml in the deploy directory, and we're going to give it an API version of apps/v1 beta 1, and the kind is going to be deployment, and we're going to set metadata with a name of, we could do web app. For the spec, we want to set the number of replicas. Just for starting out, we'll do 1. Strategy, for the type of update, we can do rolling update for when we update our deployment. And to set the config for that, we'll set a rolling update key with a max surge of 2, meaning that's the most number of containers that'll be spun up when that is happening. Max unavailable, we want to be 0. We always want our web app to be up and running, at least one container. For the deployment selector, we're going to set a match labels of, we'll set a run label of web app. And for the template of the pod, we can actually copy from our job. We can reuse some of this stuff. So if we copy the up to the containers key, and if we, actually first we should probably take in our metadata for the template. We want to set our labels to match our label selector. So if we set that run web app to match this, match labels up here. Okay, now if we delete back to the metadata inline section and paste in our containers key. Okay. So the name we'll want to change to web app. We'll want to leave the Docker image. We'll want to delete args because obviously we're not doing a database migration. We will want to add a key here to do the image pull policy, set it to always, because we're using the latest key here. So when we update our deploy, we always wanted to see if this latest tag has changed, in case we pushed a new image out. If we were tagging, say, the git commit SHA hash that like never changed, then we could take this off here, and if that tag never changed, if we're always getting new tags every time we build our image, then we don't really need this, but with the latest tag I think we do. Oh, the other thing we'll need is a ports setting to expose our container port of 3000, our Rails server port. Yeah, I think that should do it. Okay, so let's give that a try. Now we should do kubectl apply-f deploy/deploy.yaml, and we'll see what happens. Validation error, unknown field, containers. Oh, I made a mistake. Gotta put a spec here. And then tab that in. Okay, let's try it again. Okay, it created that. And now if we do kubectl git deploy, it says desired one, current one, up to date. Okay, so there's one available, so it should be running now. So if we do kubectl get pods, we will see our web app pod is running. And if we check the logs on that container in that pod, we see, okay, Puma started up, so it's ready to go. So the app is running, but we have no way to get to it. So the next thing we need to do is to create a service to connect to it so we can test it out. One way to create the service would be to write out a manifest like we did for our deploy and for our job. But another way would be to use this command called kubectl expose, which will do that for us basically. So let's give that a try. So if we type kubectl expose deployment, if I can spell it, web app, And then if we name our service, we can just name it temp service because we're going to delete it after. And if we set the type to load balancer so that it exposes the service publicly so we can access it from our web browser. And if we do protocol TCP and -- port 80 for the service port, and the target port will be 3000 for our Rails web server. So if we give that a try, should work here. So it created our service. So now if we do kubectl get service, it's going to list our load balancer here. And this other one you see over here, that's a Kubernetes internal one, so we can just ignore that. But our load balancer is created, and you can see here under this external IP category, it has a status of pending, so it is trying to allocate an IP address right now for that. So if we just do if we do kubectl get service -w, that will watch for changes, and as soon as that value changes, we should see it update here. Okay, so that value has now changed, and now we have a external IP we can visit in our browser and see what it looks like. So let's give that a try. And there we go. And our thing is running. But you may have noticed something looks a little strange here. Things aren't lined up correctly. So we seem to be missing our styles. So if we look at our browser console here, you can see that requests for our application CSS and JS file are returning 404. And you may already know the reason, but it's because since we're running a standalone Rails server without a reverse proxy sitting in front, we need to tell Rails to serve static files. So we will need to add a config value for that right now. So if we go back into our deploy, we are going to have to add another key here with the name of Rails serve static files. And if we give it a value of true, we should be able to update our deployment by doing kubectl apply-f deploy/deploy.yaml. And now if we do kubectl get deploy-w, we can sit here and watch our deploy change. So it has current 2 because it should be spinning up another pod right now to take over from the old one. So I would expect that current to drop down to 1 when it's finished. Yep, so there's the changes you can see. Available 2, so the new one had come online momentarily, and for a brief moment we had 2 current, 2 available, until it killed off the old version of the pod. So now if we go back to the app and we reload, now you can see that it looks better, the styles match up, and now if we were to upload a file, give it a caption, now we can see it's working. So that's good. But there is another problem, and that is that currently we have Shrine set up to serve these files right out of our public directory. So if we had made another change to our web app right now, for instance, if we say we added some other config value, I'll just call it foo, just give it a value of bar. If we were to deploy that, okay, I guess that happened pretty much instantly. So if we go back to the app now, and if we were to reload it, we are going to see that our image is broken now because what happened is the pod that was running before had a copy of our uploaded image in the public directory, and then once it redeployed, that pod got replaced and the new pod doesn't have that image. So the next thing we need to do is we need to move our image storage to Google Cloud Storage. So I think that's a good place to end the episode, so I will see you guys in the next episode where we implement Google Cloud Storage for image upload.